Before we go to network elements and network theorems like superposition theorem, Thevenin's theorem, Norton's theorem, maximum power transfer theorem, or reciprocity theorem, we should understand what are passive and what are active elements. So, fundamental of electronics. How you define electronics? It can be a branch of engineering which deals with electron flow through a vacuum or gas or semiconductor. We can call it as an electronics. Before we go to the fundamental passive elements and active elements, let us understand few fundamental quantities with their particular MKS or CGS units. So quantities, fundamental quantities like length, mass, time, these are nothing but fundamental physical quantities. Then the rest of all the quantities can be called as in derived physical quantities. So this is electric current, temperature, luminous intensity, and the amount of substance. So unit for this respectively are meter, kilogram, second, ampere, Kelvin, candela, mole, and the symbol is small m, kg, S, A, K, CD, and MOL. So these are all in standard international or MKS system. Now related to electronics, the physical quantities, if we take a quantity called current, unit will be ampere and symbol is capital A. Charge, coulomb, current we can define the rate of flow of charge, dq by dt. This is unit is ampere and symbol is A. The charges unit are coulomb, symbol C. Electromotive force, unless we give certain source to that particular circuit, the electrons will not be aligned into straight line and will not flow. So there should be some voltage to be given to the particular circuit. So voltage is unit is volt, symbol V. Resistance unit ohm, and it is written in this manner, ohm. Power is nothing but the product of voltage and current. So unit are watt and symbol is capital W. Let's have the difference between the scientific and engineering notation. So for an example, you have 47 thousands, you can call it as an 4.7 into 10 to the power of 7. This is in a scientific notation. Whereas if you come to engineering notation, this can be written as 47 into 10 to the power of 6. I mean, in the case of engineering notation, we always denote into the power of 3, 6, 9, 12, and 15, or minus 3, minus 6, minus 12, minus 15, minus 9, so on. So if you take the decimal fraction 0.000027, this is written as 2.7 into 10 to the power of minus 5. Only one decimal point. So 2.7 into 10 to the power of minus 5, this is a scientific notation. Whereas in the power of 10 to the power of minus 6, this can be written as 27 into 10 to the power of minus 6. So this is engineering notation. The prefixes and their meanings. So if it is written like capital P, then it is a peta 10 to the power of plus 15. T, like normally we use for terabyte. Now we prefer for 1 terabyte of memory for the laptops and for our desktops, the hard disks. So that is terabyte, capital T, tera 10 to the power of plus 12. Gigabyte is 10 to the power of 9, mega is 10 to the power of 6, and kilo is 10 to the power of 3. This is all plus. If you take in a negative one, then milli is 10 to the power of minus 3, micro 10 to the power of minus 6, nano is 10 to the power of minus 9, Pico is 10 to the power of minus 12, and femto is nothing but 10 to the power of minus 15. So here we can say that this is the highest and this is the lowest. And if you convert 0.47 mega ohm, so this can be written in the form of kilo ohm. So this can be written as 10 to mega is 10 to the power of plus 6, kilo is 10 to the power of plus 3. So we can write in the kilo, it comes like 470 kilo ohm. So ohm is the smaller unit and kilo will be the larger unit. If you take 10,000 picofarad and convert it into a microfarad, this I can say that the mega is more than the kilo, so the higher number is converted to lower, whereas here the picofarad is lowest, is converted to higher into the form of microfarad, because if you see the picofarad is 10 to the power of minus 12 and micro is 10 to the power of minus 6. So you can see that the farad, this is a larger unit and micro is a smaller number. So we can convert 10,000 picofarad into 0.01 microfarad. So what is electronic circuits? It's nothing but composed of different components that are classified as passive and active components. So what are passive now? Passive components are that do not generate voltage but controls the current in a circuit. It by itself won't generate any voltage into the circuit, but it can control the current in the circuit. So those components which cannot generate the voltage but which can control the current in the circuit are called as an passive components or passive devices. So the examples are resistors, capacitors, inductors. We will study each different types of resistors, types of capacitors as well as inductors into the next slides. These are the few pictures of the passive components, how they look like. These are few of the resistors. These are inductors, nothing but a coil, and these are few of the capacitors. All are passive components. Now, what is active? What are active components? Components that can generate, amplify, and even controls the current in the circuit. So amplification can be done in the circuit and which controls the current are called as an active components. The examples are diode, transistors, thyristors, we can say, integrated circuits also. So these are the components which are used in the circuit which can amplify the signal as well as which can control the current in the circuit. Later we will see how the diodes or transistors can be used as an amplifiers, because basically transistors are used as a switch or amplifiers, and these diodes we can use to convert an alternating current to a direct current. Rectification can be done with usage of diodes. So these are the active components. You can see the ICs, and these are the symbols of transistors, metal transistors we can say, few JFETs and MOSFETs, and these are the diodes, liquid crystal diodes and light emitting diodes, transistors and an ICs. So these are all called as an active components. Now let's elaborately understand what are resistors. A passive component, resistors. An electrical component that is used to oppose the flow of current. So we can define a resistors are electronic components used to oppose the flow of current, or resistance is the property of material which opposes the flow of current through it. And unit of resistance is what? Ohm. So this is a symbol, how zigzag manner, this is how it should be shown. And we have a formula saying that R is equal to V by I. How it comes? So according to Ohm's law, the potential difference across a conductor is directly proportional to the current flowing in the circuit. So V is proportional to I, or we can say that V is equal to I into R, where R is the proportionality constant. And this R is called as a resistance. So R will be equal to V by I. It's nothing but because it is blocking the flow of current into the circuit, so it can be called as a speed breaker. So we can minimize the speed. This is how the speed earlier, and it is acting as a speed breaker. Then we can say that the speed of that particular flow of current is minimized. So resistor slows down the flow of electrons. It is how it looks physically. If you see that, any resistor will have three strips onto one side. The another strips, this can be made up of gold or silver. So how the color coding are done? This is the first digit, first color with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 up to 9. And this is again the second digit, the same 0 to 9. And third is called as a multiplier. And this can be of into 10 to the power of 1 ohm, 10 ohm, 100 ohm, 1k, 10k. It depends on the color. We'll see into the next slide. And the fourth one, which is can be gold or silver, is called as in tolerance. So what is that? See, opposite to this gold or silver, we have to measure the resistance value, taking the strips into the count, and that strips are made up of different type of colors. How we have to remember, I'll show into the next slide. So this is first digit, second digit, consecutively we have to write first number and the second number into the multiplier of the third color code. And how we have to measure? We have to measure from the opposite of this particular gold or silver. It means from this side we have to measure. So these are the first digits numbers, second digits number, and these are the possible multipliers with a tolerance of plus or 5. If it is gold, then it is a plus 5% plus or minus 5% tolerance, and if it is a silver, it is plus or minus 10% tolerance. Let's elaborately understand what are tolerance. Allowed resistance more or less than the actual resistance. Like as we were saying that plus or minus of 5%. So it is more or less of 5% tolerance is allowed. If it is a gold, if it is a silver, then plus or minus of 10% tolerance is allowed. Multiplier used to multiply the significant digits to find the actual value of the resistor. So, and first and second digit significant read identified as is power rating of the resistor. Now let's look into here. This is carbon composition. If you see, this is how it looks like, and you can see the length also. This is almost 2 centimeter. This is carbon composition resistors. This is carbon film resistors, almost like 1 centimeter, and very small in size are metal fillets, half centimeter. This is an insulating code with a color coding printed onto that, and underneath of this particular insulating case, you have solid rod of carbon granules. And this two side, we can say that these are metal conductor and lead out. See the metal conductor, and this is the lead out. It can be a copper or it can be a metal. This is how the high power wire wound ceramic looks like. This is how it looks like. Let us understand the color coding. So if we go back to here itself we have given a colors like first digits is black, brown, red, orange, yellow, green, blue, violet, gray and white. So these are the 10 colors what we have. Here you can see the same way: black, brown, red, orange, yellow, green, blue, violet, gray, white, and this is for the tolerance gold and silver, and if there is nothing, then there is no tolerance. Okay, so this black stands for 0, brown stands for 1, red stands for 2, orange stands for 3, yellow stands for 4, green stands for 5, blue stands for 6, violet stands for 7, and gray stands for 8, and the last number, last strip is, if it is white, it stands for 9. So it comes like, 10 colors from 0 to 9. How we have to remember? This is BB Roy, ROY. BB Roy goes to, T will not have any color, it's a numeric number. So BB Roy goes to bring very good wife. I know it's funny, but this is how we have to remember the color coding of a resistor. BB Roy goes to bring very good wife. And the first B stands for black, the second stands for brown, and the third B stands for blue. Okay? Then this is as usual red, orange, yellow, green, violet. First G stands for green, the second G stands for gray. Okay, so this is the first band. We can take it as like this. Now you can understand why we have given this colored itself. BB Roy goes green to bring blue, very good wife. So how we have to take it is, suppose this is, as an example, this is a blue. So 6 is the color code for that, 6 number. So 6, and this is what? This is red. So this is 2. So 6 2 into multiplier into 10 to power of this particular number. So black stands for 1. So 6 2 into 10 to power of 1. This is black stands for how much? Black is 0, this 0. So 6 2 into 10 to power of 0. 10 to power of 0 is how much? 1. So 62 ohm. So here it is written like 62 ohm. And what it having a tolerance, is it a gold or silver? It is a gold. So gold will have a tolerance of 5%. So 62 ohm plus or minus of 5% is acceptable. So this is how the color coding of a resistor is done. First digit, second digit into a multiplier into 10 to power of the third digit, third color strip. And we have to count the first one from the opposite of this particular tolerance, like silver or gold. So this value now we can say is a 62 ohm with a tolerance of 5%. The same thing we have written with the color coding, how the first band and second band can be taken, and how the multiplier tolerance with according to the temperature. The same way, now you just see that if it is this is the first band, second band, and there is no third band, or we can say that it's a multiplier. Okay, so we can find it out. If it is a red and black, so red and black is 2 into 10 to power of 0. So this value, now we can say that it is a 22 ohm with a gold strip. It means 22 ohm with 5% tolerance. So you can say if you have a resistor with brown, red, brown, silver. So how it comes like? It comes brown is 1, red is 2. You can see here brown is 1, red is 2. So it is 1, 2, and the next number is brown again. So 1, 2 into 10 to power of 1. So how much it will be? It will be 120 ohms. 1, 2 into 10 to power of 1 is 10. So 12 into 10 is 120. So this can be called as in 120 ohms. Because there is a silver tolerance, it is 10% plus or minus of 10%. So rated value is 120 ohm. If you take the 10%, so in the lowest allowed value, it will be 120 minus, it is 12. 10% of 120 is 12. So 120 ohm minus 12, this will give as a 108 lowest allowed value. Similarly, 120 plus 12, this is the highest allowed value of that particular resistance. So it is ranging from 108 to 132 value. So if you can practice, if you have many different types of resistance, like if it is black, then this is a brown, black, red, and with a tolerance of gold. So you can have all this resistance. You can see here we have given the values also. This is brown, black, and black. So brown stands for 1, black is 0, and this is 0. Then, so how much it will be? 1, 0. It was 10. 10 into 10 to the power of 0. It is 1. So it is the value of 10 ohms. This is C, brown and red. So it is 12 because multiplier is black. So for all the resistance, just for a practice, we have given a multiplier as in black so that it will be 10 to the power of 0. So just focus on to the first two colors. So this is brown and red, so 1 and 2. This is brown and green, so 1 and 5. So 15 into 10 to the power of 0, so it is 15 ohm. So similarly 18 ohm, 22 ohm. So likewise you can practice with the color coding. So there are many color codes resistors here given. These are the commonly used resistance value: 1 ohm, 1.2 ohm, 1.5 ohm, and so forth, up to 22 mega ohms. So these are generally used in our electronic practices or devices. Power rating indicates how much power the resistor can safely tolerate. What is power? Power is nothing but voltage into current. So if I say this is a resistance and current I is flowing through the resistance, so we can measure the voltage across this resistor. Voltage is always measured in parallel. So this is V across R. So what is power? This voltage into current is nothing but power. So this VI can be written according to the Ohm's law as V square by R, or we can write it as I square into R. And the unit for power is nothing but watts. What is tolerance? It is allowed variation of resistance value from its normal value. A 100 ohm resistor with 10% tolerance means that its value can be any fixed value between 90 to 110 ohms, because 100 minus 10 will be 90, 100 plus 10 will be 110. So it is allowed value from 90 to 110 ohms if we say that it is a 100 ohm resistance value. There are different types of resistors you have, fixed resistors and variable resistors. Under the fixed resistors, you have carbon composition resistors, carbon film resistors, wire wound resistors, metal film resistors. And under this classification of variable resistors, you have potentiometer, you have rheostat, and you have a preset resistors. Let's understand now. Resistors whose value of resistance is specified and cannot be varied, or we can say that the resistors whose values are fixed can be called as a fixed resistors. We cannot change the value of resistance. Under this fixed resistance, we have four types: carbon composition, carbon film resistors, wire wound resistors, and metal film resistors. Let us understand each of the resistors. For the carbon composition resistor, the materials used are finely powdered of carbon or graphite and an insulating material like ceramic. Used for bind mixtures. And leads are copper wires. This leads we have to use made up of the copper. And this carbon composition resistors will have the resistance value from 1 ohm to 22 mega ohm. Its power rating is 1 by 8 watt or 1 by 4 watt, 1 by 2 watt, 1 watt, and 2 watt. Tolerance ranges from 5% to 20%. Size increases for a high wattage. As we go for a more power, then the size will increases. So you can see the filament type carbon composition resistor. This is a protective coating. This is the carbon dust, and this is a tin coated lead. For the carbon film resistors, it is the construction happens with the carbon film on insulating core. Here you can see these are all insulating core with a color coating specified onto that. And these LEDs are made up of copper wire. Resistance values will be from 1 ohm to 10 mega ohm. Here you can see that this is the range is 1 ohm to 22 mega ohm, whereas here the range of resistance value is 1 ohm to 10 mega ohm. The power rating is 1 by 8 watt, 1 by 4 watt, and 1 by 2 watt. Tolerance range is 5%. Low power applications, better stability. Okay, and how it looks like, this is metal lid. This is the end cap for the metal lid on the both the side. This is an end cap and this is a metal lid. This is a ceramic rod, and here you can see that the carbon film apparel away to give value, and this is an insulating coating. Above this you can see that this is a insulating coating, and above this particular insulating coating, the color codes are specified. Wire wound resistors. It is made up of nichrome wire wound around a ceramic or plastic. LEDs are copper wires protected with enamel coating. So this is not insulating coating, this is an enamel coating. Like enamel coating is nothing but you can see for the nail polish and all a kind of coating, whose resistance value is 1 ohm to 100 ohm. And power rating is high, 3 watts to 200 watts, very high power. Tolerance range is 5%. It is reliable and stable. This stands up to 450 degrees centigrade. Disadvantages is large in size, high cost, and poor high frequency response. You can see this is a cap, this is a wire, copper wire, and this white one is an insulating foam, and this is a coil made up of nichrome. Okay, and again this I can say that this is a cap and this is particular wire. So this is wire wound resistor. The last one is metal film resistor, made up of nichrome, LEDs are copper wires, and here the tolerance range is 0.05%, more better than the previous one because the tolerance is less. Low temperature coefficient and good stability, more accurate. So construction efficacy, this is the insulating core, like protecting one, and this is thin metal film. You can see here. This is a ceramic carrier, and this is the end caps with LEDs. This is an end cap with particular LEDs, and this cut is helical cut to reach the desired resistance value. So these are called metal film resistor. Now the next is variable resistors. So resistor whose resistance can be varied, unlike the fixed resistance. So where we have an option to change the value of resistance according to our own applications. So those are called as in variable resistors. Applications can be changing volume of sound, brightness of television picture, etc. Even a fan regulator we use it. So as the R value change in the case of fan regulator, the current passed to the motor can be increased or decreased, and appropriately the motor can speed up or speed down. So this is all because of the Ohm's law principle only. So if I change the value of R in the circuit, the current in the circuit can be varied, like low or high. So these are called as in variable resistance with few different kind of an applications. It is pot resistor. It can be called as in potentiometer or pot resistor. So variable resistor with 3 terminals. Here in the picture you can see that there are 3 terminals. Unlike the fixed resistance will have 2 wires, 2 terminals. So variable resistors with 3 terminals, 2 at the ends of the resistor material and 1 to a sliding contact. Now you can see a physical diagram. This is the first contact This is the second terminal, first terminal, second terminal, and this is a sliding contact. You can see that this is a slider. See here, this is a slider. So this is a casing, this is a slider. You can say this is an axis where which an option of rotating it. This is an insulating body, and this is a resistor. So through this slider, we are changing the value of resistance because this is a resistor material. Unlike fixed to 1 and 2, we can vary through this axis, through this particular slider, the resistive value C. And this 1 and 3 knobs over here can be called as a connector. So variable resistor with 3 terminals, 2 at the ends of the resistor material and 1 to a sliding contact. Manufactured as carbon composition, metallic film and wire-wound resistors. Can be made up of all these 3 types. Both linear as well as non-linear. Applications can be changing volume of sound, brightness of television pictures, contrast control, etc. Normally, this is rheostat. In laboratories, in physics laboratories, we use a rheostat for a variable resistance value for many of the experiments. It is a wire-wound variable resistor. If you go for a Carey-Foster bridge or any kind of a bridge, we normally use a rheostat. A resistive wire is wound over an insulating ceramic core and wiper slides over the winding. Here you can see that. This is current in and this is current out. Okay, this is a wiper. It is in contact with the coil of the wire, and this is how the current flows from current in to the current out. So we can say that this is a A point, this is a B point, and this is a C point, and this is a coil of a wire. So a resistor wire is wound over an insulating ceramic core and wiper slides over the winding. This wiper is sliding over this particular winding. You can see that. We can slide this particular wiper over the winding of this particular ceramic core. Applications are high power applications, controlling the speed of motor, intensity of light, etc. Now we have the third type called as a preset. Used where variation of resistance is not done frequently. Once the setting is made, it may be undisturbed. So once the setting is done appropriate to our application, then again we won't require at all. So there we use resistors called a preset, made up of carbonized or metallized ceramic. Metallic wiper can be moved from a screwdriver. So here you can see a knob, a little knob. So through the screwdriver, we can set it according to our desired application. And once it is set to the desired one, no need of again doing it again and again. So used where variation of resistance is not done frequently, and these are called as presets. Applications where setting line frequency and frame frequency in a TV receiver. Once the TV receiver sets to that particular frequency value, we don't require again and again, isn't it? So there we use a presets kind of resistors. If you recap the types of resistors, as a fixed resistors, you can have a tap resistors. These tap resistors are nothing but a wire-wound fixed resistors having one or more additional terminals along its length. See, you can see that this is one terminal, this is second terminal, we will have a third terminal over here. So wire-wound fixed resistors having one or more additional terminals along its length are used to reduce current flow, adjust signal levels, to divide voltages, bias active elements, and terminate transmission lines are the usage of this particular tap resistors. Potentiometer you have seen is used in circuits to vary the magnitude of resistance passing through the resistors. Trim resistors or presets, we can say that is a miniature variable resistor, we can say rheostat, used mainly in place of a fixed resistor, permit convenient adjustment of resistance in a circuit. And LDRs are nothing but what? LDRs are nothing but light dependent resistors used to detect levels, light levels. For example, in automatic security lights, see, LDR's resistance decreases as the light intensity decreases. In the dark and at low light levels, the resistance of an LDR is high and little current can flow through it. So these are nothing but devices that do not change the resistance as exposed to the external photon sources. You can see this is a metal contact. This is a cadmium sulfide track. Now let's understand the next passive components called the capacitors, because we have given an example of passive as resistors, capacitors and inductors.